All right. Going to talk about 7.4, solving multiplication and division equations. Basically, there's two types of equations that we're going to look at today. The first type is one like this, 14q equal 42. The other type we'll be looking at is one similar to this, w over 2 equal 8. Okay. In both of these, we're trying to, just like we have in the last section, 7.3, we're trying to isolate the variable. We're trying to find out what the value of the variable is. So in other words, they're saying 14 times some number is going to be equal to 42. Well, we know if we take 14 times 1, that would be 14. 14 times 2 would be 28. 14 times 3 would be 42. Now, how we find that out without having to do that process in our mind is we do the inverse operation. Okay, we're going to do the inverse operation. The inverse operation of multiplication is division. And so we're going to divide both sides of the equation by 14, because that's what we're multiplying by G or Q. 14Q. Yeah. Yeah, sort of like your pipe cleaners of Captain America. Just put the Q down. It's a Q. Yes, it's the only way you can solve it. Okay. I'll give you one. 4/9 x. 4/9 times x minus 7 equal 31. Are you going to mentally solve that one? 4/9 x minus 7 equal 31. No, not even close. Jesse, hurry up. Okay, now, haven't solved it yet. Now, so yes, you do have to write down these steps even if you can solve them mentally, because you're not going to be able to solve every one of them mentally. So the 14 over 14 cancels each other out, leaving us with 1. We know that 1 times anything is the number itself, and so basically then we have Q left on the left side. On the right side we have 42 over 14, which is an improper fraction. We've got to take and make the improper fraction either a mixed number or whole number. In this case, it's going to be a whole number because 14 goes into 42 3 times. And so the answer to 14 times Q equal 42 is 3. We obviously did that in our heads by going 14 times 1, 14 times 2, and things like that, and figured it out. But that's the process that we need to use using the inverse operation to solve any type of problem that has multiplication in it. Okay? Now, the other one, w over 2 equal 8. Okay? This is division. So we're going to use the inverse operation here to be multiplication. Isaiah? Okay. When there's a number right next to a variable, it means to multiply as long as there's not a sign in between the two. So the original problem was 14q equal 42. So this right here, I have to be doing some type of mathematical operation. The only one that I can be doing, since there's no sign in it, is multiplication. And so I know it's multiplication. So I know the inverse of multiplication is division. $42, that was the original problem. Hush. The 42, 14q equal 42. That was the original problem. That's problem number 2 in your book. Okay. All right, W over 2 equal 8. As I stated here, the inverse operation we need to use for solving this one is multiplication. So here, we are dividing by 2. The inverse of dividing by 2, understand that this problem is the same as the first problem. Okay, W over 2 and W division sign 2 is exactly the same problem. Okay, and so we've got to solve it using the inverse operation. The two ways we can show that is this. I can do W divided by 2 times 2 equal 8 times 2. That's one way I can show it. Or I can show it this way. I can multiply both sides by 2 because I'm dividing by 2. Either way is fine. This way here, W division sign 2 times 2 equal 8 times 2. That's the way we did it last year in 6th grade. Okay? This is the way eventually that you need to look at it, be able to see it, and do it that way. Because this is the way they're going to list your problems. They are not going to list your problems W division sign 2 equal 8 from now on. They're going to have to assume that you understand that W over 2, the fraction W over 2, is the same thing as division. Okay, and so that's how they're going to list your equations. Trinity, you getting all this? It's funny because I don't see any of it down. Yeah. You might want to get out a pen. Quit worrying about the glue on your hands. Okay, now, to finish solving this, the divided by 2 and the times 2 on the left side of the equation cancel each other out. Okay, same thing is true on this one over here to the left. The 2 times W over 2 cancel each other out. Okay, both of them leave us with W equal to whatever 8 times 2 is. What is 8 times 2? 16. So W would have to be equal to 16. Okay, now, you can always go back and check it by plugging in the value of W into the original equation. So 16 over 2 is equal to 8. This is how we check it. Okay, well, what is 16 over 2? 8. So 8 is equal to 8, so it does check. Okay, so those are the two of the types of problems that we're going to see today. Okay, let's do another of the multiplication one. 9s equal negative 27. Then we have negative 3/4 y equal 12. Okay, so now both of these equations have negative signs in them. So therefore, let's remind ourselves what our rule is for multiplying or dividing by negatives. If you multiply by one negative or divide by one negative, the answer is negative. Okay, let me restate that. If you divide or multiply to solve the expression by one negative, the answer is negative. If you have two negatives in the equation that you're solving, then it's going to be a positive answer. Okay? Both of these problems only have one negative in the problem. So in other words, 9s equal negative 27. How many negative signs are there? One. That means it's going to be a negative answer. However, if I had negative 9s equal negative 27, then the answer is going to be positive. Okay? That's the difference between the two. All right, now, we solved this problem. We have 9 times s equal negative 27. The inverse of multiplying by 9 would be to divide both sides by 9. So I divide the left side by 9, and they cancel out. I divide the right side by 9, and once again, That's just an improper fraction. Okay? Just an improper fraction. Okay, so I reduce that improper fraction. I'm not done yet. I have to reduce it. Okay, and all I'm really doing is this. 9 into 27. 9 goes into 27 3 times. So S is equal to -3. Brandon? Because I have one negative sign. And since I just said, since we have one negative sign in this equation, what's the answer going to be? And what did y'all say? And Tristan was wrong, and the rest of the class said negative. You must have been off in Space Invader land or something. You were thinking about your next strategy for Boom Beach or whatever you were playing this morning. Huh? Well, I'd hope so. You stormed it 10 different times and lost 1,000 people. How many people did you lose? Huh? You lost 5 people? I saw you get 4 people killed the first time. Hey, we're going back on task now. We're going back on task. Okay. So, S equal -3. Now, if we look at the other equation, -3/4 y equal 12. You need to write this down, what I'm fixing to put down. When you have a fraction, you getting this, Tristan? When you have a fraction in front of the variable, to solve the equation, you must multiply both sides of the equation by the reciprocal of the fraction. Now, as we've already learned in previous sections, when we were talking about fractions, we're talking about in Chapter 5 adding fractions, we talked about dividing fractions, multiplying fractions. When you divide a fraction, we have to multiply by its reciprocal to solve or simplify the problem. Okay? Well, this is the same thing here. All right? Let me give you an example of what I'm talking about. If we had 8/9 divided by 3/4. To simplify that by our rules for multiplying fractions, we'd have to take 8/9, change that to multiplication, do the reciprocal of 3/4, which is 4/3. And then we would multiply it out. Okay? Well, you're doing the same thing with this equation. I'm going to rewrite the equation over here so I can get it all on one screen. Okay? With the equation -3/4 y equal 12. Okay? Well, what are you doing mathematically in that problem? Am I multiplying or dividing in that problem? I'm multiplying. 3/4 times y. That's what that says. There is no sign in between the variable and the numbers, so therefore that means multiplication. Well, what is the inverse of multiplication? Division. So realistically, we have to divide this by 3/4. But when we divide by 3/4, we just proved that you multiply by the reciprocal. You don't actually divide. So that's what we're going to do in this problem. To solve this problem, we're going to take and multiply both sides by -4/3. 4 over 3. Okay, on the left side, this cancels out because it's equal to 1. On the right side, we can cross cancel. 3 goes into 3 one time, 3 goes into 12 4 times. And so that leaves me with y is equal to 4 times negative 4 on top, 1 times 1 on bottom. And that gives me y is equal to negative 16. And so that is your answer. So basically what they're saying is this. If I take 3/4 and multiply it by 16, that's going to give me 12. Okay, now there's negatives thrown in there that I didn't throw in there, but that's what they're basically saying. If you take 3/4 of a whole number, 16, then I'm going to end up with 12 left over. Okay, if I take half of 12, if I take half of 16, how much would I have? 8. Okay, if I take 3/4 of 12, 3/4 of 16, I have 12. If I take all of 16, I have 16. You might want to keep your hand right there. All right. Let's look at another example. $30B, 30 times B equal 5. 30 times B equal 5. Isaiah, that's a B. 30 times B equal 5. All right? So, 30 times B equal 5. And here's what you do. To solve this problem, we divide by 30 to both sides because that's what we're multiplying by B is 30. And so the inverse operation of that is to divide by 30. Okay? Over here on the left side, 30 over 30 is 1, so that just leaves me with B. Now here's the difference. This is a proper fraction. It is not an improper fraction like we've been dealing with up to this point. It is a proper fraction. So, Brandon, what do I have to do to proper fractions? It begins with an R, and it's not reciprocal. There you go. We reduce them. So, 5 over 30 can be reduced by 5. 5 goes into 5 one time, 5 goes into 30 6 times. So B is equal to 1 over 6. Gabby?
Why do we do the reciprocal for the other problem?
Because it's a fraction. And when you're dividing by, see here, we're dividing by a whole number. So I don't have to do the reciprocal. Now, realistically, what is the reciprocal of 30? 1 over 30, right? So, realistically, you are doing the same thing. You have 30B equal 5. Well, the reciprocal of 30 is multiplying by 1 over 30. Those would cancel out, and you would multiply by 1 over 30 here. 1 times 5 is 5, 30 times, and you still end up with the same thing. So actually, you're, in realistic terms, in mathematical terms, you're actually multiplying by the reciprocal on both of them. It just looks different because you're not dealing with a whole number, you're dealing with a fraction.
But do we even have to worry about getting there?
Yeah, but you have to do, in other words, you can't, back up here with our original problem, and I'll do another one here in a second, if you don't do the reciprocal here, in other words, if you just say 3/4 times 3/4, well, that's 9/16. And that means so you have 9/16 in front of the y instead of 1. So that's why you have to do the reciprocal. We have to create a 1 over here on the left side, and the only way you can do that with a fraction is multiply it by its reciprocal.
And so if the fraction is there's just like a fraction in front of the problem, that's when you know to do the reciprocal.
Yeah. Yeah. Anytime there's a fraction in front of the variable, you do the reciprocal to solve it. All right, let's look at a/3 equal -4. a/3 equal -4. Okay, so here, once again, I'm dividing 3 into a. So the inverse of dividing 3 is to multiply both sides by 3. So I'm going to take and multiply this side by 3, and I'm going to multiply the right side by 3. The 3's on the left side cancel each other out, leaving me with a. Then I have -4 times 3, which is -12. So you have a is equal to -12. I do? Tomorrow, yeah. All right, let's look at this one. D over 24 equals -0.5. Now, our process doesn't change just because there's a decimal. It's still the same process as the one we just did. We just said that if we have the expression a/3 equal -4, to solve it, we multiply both sides by 3. Okay, well, you have the same type of problem here. I have d over 24 equal -0.5. So if I solve that one by multiplying by 3, because I was dividing by 3, I solved this one the same way, except now I'm dividing by 24. And so to solve this one, we simply take and we multiply by 24. I get it. To both sides. Well, the 24s on the left side cancel out, leaving me with D. 0.5 times 24 is this right here. And that would be 5 times 4 is 20, carry my 2, 5 times 2 is 10, plus 2 would be 12. I have one decimal spot, so that's 12.0, which is 12. And it is -12. It's -12 because of that negative sign. Doesn't matter. Has nothing to do with it. All right. Let's look at another decimal one. -1.2 s -1.2 s equals -6. Hey, once again, now we have a decimal and we're multiplying. Okay, So that means to solve it, what do I have to divide? I have to divide 1.2. So I have to divide by negative 1.2 to both sides. Once again, all of these have been on the left side, but it's the same if it was on the right side. Left side, the negative 1.2's cancel each other out. On the right side, we divide 1.2 into 6. The problem you have is you can't have a decimal on the outside of your division bracket. So I have to move it one place to the left on the outside and one place to the left on the inside. And so that gives me 12 into 60. Oh, yes, thank you. Okay, so 12 goes into 60 how many times? 5 times. And that would be 60, remainder 0. Now, up top, I had 2 negative signs. So 2 negatives when you're dividing or multiplying means you have a what? Positive. So that means S, let me change colors, S is equal to 60. Do what? Now, remember the decimal's on the right side of the 0. Huh? Oh, yeah. Yeah, I wrote what was underneath the bracket. Huh? I guess I'll be on my A game when I'm filling out report cards this afternoon.
Oh my goodness. Well, you're gonna give us all A's? Oh my
No. No. All right. Now. All right. All right, last one with decimals. Negative 36 equal x over 5.5. All right. Now, negative 36 equal x over 5.5. Remember that these two expressions are exactly the same. They are equivalent. Okay? So whichever way you see to solve it, then rearrange it like you need to rearrange it. Now, you will notice that I took everything that was on the right side here and moved it to the left side and did the same thing on the left side. You can't just take, I like the x over here, so I'm going to put it over here and leave the 5.5 over on the other side. Okay, that is one number. It is a fraction. It is connected together. Now, I'm going to do it this way so you can see that it's still the same process. So, here I am dividing by 5.5. The inverse of dividing by 5.5 is to multiply by 5.5 to both sides. So that's what we're going to do. We're going to take and multiply by 5.5 to both sides. On the right side, it cancels, leaving me with x. On the left side, we simply take 36 times 5.5. Okay, this is 18. And this is 180. And that gives me 198. And I have a decimal. So I have to move that decimal one place to the left. Okay, and that gives me 19.8. So X, now it is also negative 19.8. Did I copy it down wrong? Oh, that's right, because I'm dealing with 36, not 3.6. That is 198. Okay? So that's supposed to be 1 over. That's supposed to be that. And that's supposed to be that. Okay? So that should be 198. Because I had lost a 0 there. That 0 should be right there. Okay, so you move it one place, be 198. Okay? So your homework. Homework is 7.4. 2 through 25. Now hang on, 2 through 11 and 16 through 25. Okay, that is due tomorrow, obviously. Got about 8 minutes left.